So we're going to prove that if x and y are any random variables, then the expected value of x plus y is equal to the expected value of x plus the expected value of y. So of course, we're dealing with two random variables, so this is going to be a joint probability function. So that's why I have that table. So let's go ahead and start this proof. So the expected value of x plus y. So by definition, this is going to be the sum from j equals 1 to m, right? And the sum from I equals 1 to n, right? For the y sub i's from 1 to n, right? So since this is the expected value of x plus y, this will be x sub j plus y sub I times the probability that x is equal to x sub j, y is equal to y sub I. Right? So now we're going to distribute this. So this is equal to the sum, j equals 1 to m, the sum, I equals 1 to n, of x sub j, so let me put this parenthesis, times the probability that x is equal to x sub j, y is equal to y sub I, plus y sub I times the probability that x is equal to x sub j, y is equal to y sub I. Right? So I just distributed that, right? And now, remember, it doesn't matter how I add these together, right? Since we're just doing the sum of this and the sum of this guy plus this guy, well, I can just do the sum of this plus the sum of this guy here, right? So this is equal to the sum from j equals 1 to m and the sum from I equals 1 to n of x sub j times the probability that x is equal to x sub j, y is equal to y sub I, plus the sum from j equals 1 to m, the sum I equals 1 to n of y sub I times the probability that x is equal to x sub j, y is equal to y sub I, right? And look what I have here. This is the definition of the expected value of x, and this is the definition of the expected value of y. So this is equal to the expected value of x plus the expected value of y. So this is a pretty obvious theorem because from the definition, we're just adding, we're adding the two together and multiplying by each probability. But of course, we can just separate them and do them individually, right? When you break it down like this.